A milk chocolate bar is packaged in a box shaped like a triangular prism. The two bases are congruent equilateral triangles, and the three faces are congruent rectangles. This bar is available in 1 and 23 hundredths ounces, 2 and 46 hundredths ounces, 3 and 69 hundredths ounces, and 4 and 92 hundredths ounces sizes. Using the values in the table, write a function for the length of the boxes, the area of the triangular base, and the volume of the boxes. If the chocolatier plans to put a new 11 and 7 hundredths ounce bar on the market, what would be the volume of the packaging box if the triangle side length is 9 inches? Okay, so it asks us here, using the values in the table to write functions first for the length of the boxes, the area of the triangular base, and the volume of the boxes. And so let's go ahead and just notice here we're going to be doing these last three columns, finding the functions for those. And notice that our input here is going to be the side length s, since it's L of s, A of s, and V of s. And so let's just note first of all that it does have a delta x equal to 1 because it goes from 0 to 1, 1 to 2, and it just increases by 1 each time. So first looking at the box length in inches, then let's go ahead and find the finite differences. So 16 8/10 minus 12 and 6/10 is 4 and 2/10. And similarly, subtracting 12 and 6/10 minus 8 and 4/10, we also get 4 and 2/10, and we get the same thing for the last two as well. And so this will be a linear function since it has the same first difference. And so then we know that we need to find m, and so m is equal to delta y divided by delta x. In this case, delta y is 4 and 2/10, and then we already noticed on the last page in the table that delta x is 1. And so 4.2 over 1 is just 4 and 2/10. And then we also need to find the y-intercept, and so the b value in this case will just be 0, since we know that s was equal to 0 on this first line in our table before. So b will equal 0. And so our final equation will be L of s equals 4 and 2/10 s. And then plus 0, we don't have to put that. So there's that function. And then for A of s, we'll do the same thing, finding the finite differences. So now subtracting the next set, then 3 and 31 thousandths minus 2 and 165 thousandths gives us 866 thousandths. And subtracting the next pairs sequentially in the same order, then we do get this same difference each time. And so we do know now it's a quadratic. And so then to find this equation, then we first know that 2a will be equal to the second difference, which in this case is 866 thousandths. And so then dividing by 2 on each side to solve for a, then we get a equals 433 thousandths. And then to find b, we know a plus b equals the first difference between x equals 0 and x equals 1, or in this case s equals 0 and s equals 1, which would be these first two rows. And so the first difference is going to be 433 thousandths. And again, this was our second difference. So then a we found was 433 thousandths. And so then plus b will equal 433 thousandths. Well, then b must equal 0 to make this equation be true. And so there's that. And then for c, that's going to be the y-intercept. And so when s equals 0, then the y-intercept, or a of s, is 0. And so that means c equals 0. So then writing out that equation, then we get a of s equals 433 thousandths s squared. And then because b and c are 0, we don't need to put anything else. And then our last function, we need to find the volume. And so that is going to be v of s. And so to find the volume, the volume formula is just going to be, it's the area of the base times the height, which is basically the length of the box. And so in this case, then it's just going to be equal to the area of the base, which is a of s, and then times the length of the box, which is the same thing in the formula as the height, since it's the height of that prism. And so then subbing in our formulas, then for a of s, we can go ahead and plug in 433 thousandths s squared, and then for L of s, so it'll be multiplied by 4 and 2/10 s. So then 433 thousandths times 4 and 2/10 is 1 and 8,186 10,000ths. And then s squared times s is s cubed. And so there's our volume formula. So now their last question is, if the chocolatier plans to put a new 11 and 7 ounce bar, 11 and 7/100 ounce bar on the market, what would be the volume of the packaging box if the triangle side length is 9 inches? And so if our new length is 9, what's going to be the volume? So all we need to do is just plug in 9 for S in our new equation. Doing that, then V of 9 will equal just 1 and 8,186 ten thousandths times 9 cubed. And typing that in the calculator, we get 1,325. And if we round this, 76 hundredths. And then that would be inches cubed since it's volume. And so let's go ahead and summarize then all of our answers here. The length function is linear. L of s equals 4 and 2 tenths s. The area of the triangular base is a quadratic function. A of s equals 433 thousandths s squared. The volume function is a cubic function, the product of the area of the base and the length. V of s equals A of s times L of s equals 433 thousandths s squared times 4 and 2 tenths. S equals 1 and 8,186 ten thousandths s cubed. V of 9 equals 1 and 8,186 ten thousandths times 9 cubed equals 1,325 and 76 hundredths inches cubed.